Good afternoon and welcome to this afternoon's class. Today we will be looking at another very important distribution in statistics called uniform distribution. It's called a uniform distribution. Called uniform distribution. Uniform distribution. So the question here is, what is a uniform distribution? When do we say that a distribution is uniform? A uniform distribution is a type of probability distribution where the outcomes of a random experiment between interval of values have the same chances or likelihood of what of occurrence. The outcome of that random experiment or the outcome of that random variable between interval of values, each of the outcome have the same chance or likelihood of what of occurrence. Once we have such a distribution, it is described as a uniform distribution. A live example of this uniform distribution could be seen in the toss of a fair die, where a fair die is made up of 6 faces, ranging from 1 to 6, and each of these faces have the same chance of what of occurrence or the same probability of occurrence, which is what 1/6. It can equally be seen when an interval of values are defined, and then a sampling of observations now are made within this interval. Each observation drawn from this interval have the same chance or likelihood of what of occurrence. So such is what we describe as uniform distribution, a kind of a probability distribution where the outcomes of a random experiment or the outcomes of what of a random variable, each of them have the same likelihood or the same probability of what of occurrence. That is what we call uniform distribution. This uniform distribution is categorically classified into two, and then the classes are: one, discrete uniform distribution and continuous uniform distribution. We have what we call discrete uniform distribution. Number one, discrete uniform distribution. Permit me to write DSTN as a distribution. And then number two, we have what we call continuous uniform distribution. So another bigger question becomes, when do we describe a uniform distribution to be discrete uniform distribution? And when do we describe a uniform distribution as a continuous uniform distribution? Now, in the discrete uniform distribution, which of course is the topic of our discussion for today, permit me to remove what came up on my phone. Yeah. In the discrete uniform distribution, the number of occurrences or the number of what outcomes between the interval of values are countably finite. That is, the outcome of that random experiment or the observations of that random variables between the interval of values are countably finite. And each, like I had earlier said, of the outcomes between this interval of values have the same chance or probability of what of occurrence. Once we have a situation like that, we describe such a uniform distribution as discrete uniform distribution. So in the first place, it is a uniform distribution because all the outcomes between the interval or all the values of the random variable, they have the same chance or probability of occurrence. That alone has made it to be a uniform distribution. Why now do we say, in addition, that it is a discrete distribution? We say in addition that it is a discrete distribution because we are saying that the outcomes of this random experiment or the values of this random variable between these intervals are countably finite. When it happens in this way, we describe it as a discrete uniform distribution. But in the continuous uniform distribution, the number of outcomes or the values of that random variable between the intervals are infinite. In fact, they are uncountably infinite between the interval of what of values. And of course, we are going to showcase the PMF of a discrete distribution, the PDF of a continuous and uniform distribution, expected value of a discrete uniform distribution, expected value of a continuous uniform distribution, variance of a discrete uniform distribution, and then variance of a continuous uniform distribution. At the end of which, we now go into detail of proving these formulas now under the discrete uniform distribution in our today's lessons or class. So under discrete uniform distribution, discrete uniform distribution, then here becomes a continuous uniform distribution. This is continuous uniform distribution, just wanting to manage the size of my board. Then the probability distribution function, that is the mathematical function that assigns a probability value to each of the outcome of a discrete uniform distribution, is given as P of capital X equals small x is given as 1 all over what? N, where the value of this x begins from what? 1, 2 down to n. So each outcome of this random variable x, each of the outcome of this random variable x, which is small x, which it could be 1, which it could be 2, down to n. The probability in each case is 1 over what? 1 over n. So you find out that this probability is independent of these observations of this random variable. So even if 1 occurs, the probability is 1 over n. If 2 occurs, the probability is 1 over what? N. So it has a uniform distribution. Then the expected value of a discrete distribution is given as what? E of x is given as what? N plus 1 all over what? 2. So the moment we know the number of occurrences or the number of outcomes of that random variable, we can actually determine the expected value of that by saying the number of what? Of the outcomes plus 1 all divided by what? By 2. While the variance is given as var of x is given as what? N raised to power 2 minus 1 all over what? All over 12. So what becomes the PDF, probability density function, for the continuous uniform distribution? What becomes the variance and the expected value for the continuous uniform distribution? It is given as that f of x is given as 1 all over b minus a, where now a is less than or equal to what? X, which is less than or equal to what? B. So it is a continuous interval ranging from what? From A and end at what? At B. Then the variance is given as, the expected value is given as, we say E of x is given as, we have what? B plus A all over what? 2. B plus A all over 2. And then we have that the variance var of x is given as b minus what? A all raised to power 2 all over what? 12. So it is important you can make some little notes in your notebook regarding the PMF of a discrete uniform distribution defined as this under this range. So the range of a discrete uniform distribution begins from 1 and ends at what? At n. And its probability at every point in time is defined as what? 1 over n. That's why we say it is a uniform. The expected value of a discrete uniform distribution n plus 1 all over 2. The variance n raised to power 2 minus 1 all over what? 12. Then we come over here for the PDF, like I had earlier said, is 1 all over b minus a. So any value of this random variable x between this interval a and b inclusive, the probability is 1 all over a minus what? B. When, of course, we know that ab initio, the interval must have been defined. So any value you pick in between this interval, the probability still returns 1 all over b minus a. And that's the reason why we are saying that it is a uniform distribution, even though it is continuous over this interval. Then the expected value of a continuous uniform distribution is b plus a all over 2. And that of the variance is given as this. So it is important to be able to distinguish between the PMF, the PDF of discrete and continuous uniform distribution, expected value of discrete and continuous distribution, and then the variance of discrete and continuous uniform distribution. And like I had earlier said, our focus for today is on discrete uniform distribution. So we are going to go over to showcase that the expected value of a discrete uniform distribution is given as this, and then its variance is given as this, before we now begin to take some questions under it. So permit me to wipe down this board. So we want to show that the expected value of a discrete uniform distribution is given as n plus 1 all over 2. So we are talking about E of x for a discrete uniform distribution is given as n plus 1 all over 2. And somebody is asking us that we should show that this is given as this. Permit me to bring down my curtain. Reflection of light is coming into the class. I think it is better this way. Okay? So somebody is asking us to show that this is equal to this. So what are we going to do? We are going to go ahead to define the formula for the expected value of any random variable, any discrete random variable. And then the expected value of any discrete random variable is given as E of x is given as sum over the range of x p of capital X equals small x. This is the formula for the expected value of any discrete random variable. So we are now going to say but p of capital X equals small x for this discrete uniform distribution is given as 1 all over what? N, where this x takes a value 1, 2 down to n. So I will come back to this formula. Wherever place I see p of capital X equals to small x, I will quickly replace with 1 over n, because that is, of course, the PMF of a discrete uniform distribution. So I will now say, therefore, my E of x is given as sum over the range of x, which is here. Look at my x here, of x. Instead of writing p of capital X equals small x, it is going to be replaced with what? 1 over n. So multiply by 1 all over what? N. And it is important that we note that 1 over n is a constant given this expression. And because it is a constant, it is expected to be brought outside or behind the summation. So this equals 1 all over what n sum over the range of x of what of this x that is here. But then we have an information that the range of x begins from 1 to n. So if I come here now, the range is now going to start from what? So this x now starts from 1 and ends at what? At n. So what I have here now is summation of a natural numbers. First n natural numbers, beginning from 1 and getting to what? To n. Okay? And we know quite all right that the sum of the first n natural numbers is already given. It is given as, we now say, but sum of x ranging from 1 to n of x is given as what? N into what? N plus 1 all over 2. This thing has been given. That is the sum of the first n natural numbers, beginning from 1 and end at what? At n. So I will now say, therefore, my E of x, which is this, is given as 1 over n is outside, 1 all over what? N, multiplied by. Instead of writing this sum, x running from 1 to n of x, I am now going to replace with its value, which is n into n plus 1 all over 2. So we say n into n plus 1 all over what? 2. I have n here and I have n here. So something can go. So this n will cancel this n. And what I have here at the numerator is 1. And 1 multiply n plus 1 remains n plus 1. So I have n plus 1 as my numerator value. What I have under is what? Is 2. So I have all over 2. And by this, we have shown that the expected value of a discrete uniform distribution is given as a n plus n all over 2. N plus 1 all over 2. So what we have done so far is not difficult, but in case if you're having challenges, remember, we always employ you to drop your concern in the comment section. We always reach out to people who reach out to us, asking us some questions in some of the things that we do in the class here. So this is how to show that the expected value of a discrete uniform distribution is given as a n plus 1 all over 2. Now we want to go and show the variance. And earlier on, I had said that the variance of a discrete uniform distribution is given as var of x. Var of x is given as, we have n raised to power 2 minus 1 all over what? 12. So how do we show that the variance of a discrete uniform distribution is given by this? That's what we are going to face now. So we are going to permit me to wipe this place down. If I wipe it down now, then we now go ahead proving that of the variance. So permit me to clean that. Do remember that we already had proved the expected value, and the expected value is given as what? As E of x is given as what? N plus 1 all over 2. We are not going to forget this because we already have proven that. Okay? Then we now come and say variance of x, var of x is defined as E of x raised to power 2 minus E of x, all in brackets raised to power 2. This is the definition of the variance of any random variable, be it continuous or be it discrete. I will now say but E of x squared is defined as sum over the range of x raised to power 2, P of capital X is equals small x. Okay? By this definition now, we are now discussing discrete random variable. Because it is in discrete random variable that we talk about what? Sum. If it were continuous, we should be talking about integral over the range. Here it is sum over the range. But we know ab initio that the PMF of a discrete uniform distribution is given as a 1 over n. So I will go ahead again and say and P of capital X given as small x is given as what? 1 all over what? N. For the range x beginning from 1, 2 down to n. So what I'm going to do here is to revert back to this formula. Anywhere I see P of capital X small x now, I will replace with 1 over n as usual. So it is now going to be E of x raised to power 2 is given as, here is sum over the range of x, this x here, x raised to power 2, which is what I have here. Instead of writing this P of capital X equals to small x, I'm going to write multiply by 1 all over n. This 1 over n is equally a constant, so we can factor it outside, or we can bring it outside the summation sign, and then this implies 1 all over what? N sum. The range of this x begins from 1 and ends at what? N. So x beginning from 1 and ends at what? N of x raised to power 2. So what we now have here becomes the sum of the first n square natural numbers. That is squaring first n natural numbers and summing them up. That's what this means. And it has been given, it has been defined that the value of this sum is say but sum of x ranging from 1 to n of x raised to power 2 is given as n into n plus 1 into 2n plus what? 1 all over 6. You have to note this, that if you are to sum the first n squared natural numbers, whatever thing you are going to get at the end, if you apply this formula, you are going to arrive at the same answer. Okay? So this is this. So if this is this, what am I going to do? It becomes simple. I'll say therefore, my E of x all raised to power 2, which is this, is now equals. What I have here is 1 over n. This is 1 over n. So I have 1 all over n multiplied by. Instead of writing this sum of the first squared natural numbers, I'm going to replace with this. So I'm now going to write this in this way. It becomes n into what? N plus 1 into what? 2 what? N plus 1 all over 6. This is what I'm going to write. And of course, you can see that I have n here and I have n here. Therefore, something can go. So this will cancel this. And what I have now left becomes this. Because what I have left becomes this now, we now go ahead. Permit me to divide the board then. We now go ahead. Now, our variance is var of x is given by this minus this. And we have shown that the whole of this one is given as this. So I will now say, therefore, my var of x equals, the whole of this has become this. So what I have here becomes what? N plus 1 into 2 what? N plus 1 all over what? 6 minus. Look at minus here. What is inside this bracket is E of x, which is the expected value of the uniform distribution discrete uniform distribution that we proved earlier. So I'm going to put it inside this place and square it. So what I have here becomes what? I have n plus 1 all over what? 2 all raised to power 2 because of this power here. So this thing now becomes that this equals, I have n plus 1 into what? 2 what? N plus 1 all over what? 6 minus. Squaring this thing will now make me to have what? N plus 1 all squared. These two squared will give me what? 4. Then I will now look for LCM of 6 and what? And 4. And the LCM of 6 and 4, of course, is what? Is 12. So I now have 12. I now write 12 this way. I now write 12. And I ask, 12 divided by what? By 6 will give me what? 2. So I will now have 2 here. I will open this bracket. I will now write what I have inside, which is n plus 1 into what? 2n plus what? 1 minus. I will now say 12 divided by what? 4 will give me what? 3. So I will now write that 3 here, and I will now open a bracket. And I have n plus 1 all raised to power 2. Then I will now come in a way to expand this. And in a way to expand this now, this thing becomes, I have here to be 2, outside here I have it to be 2, I'll open a bracket. N times 2n squared will give me, n times 2n will give me 2n squared. The sign here is what? Plus. N times 1 will give me what? N. Here is my 1. 1 times 2n will give me what? 2n. Here is my 1. 1 times 1 will give me 1. I will close the bracket minus. I will come here. This is my 3. I will open a bracket. So here now I have what is n plus 1 into n plus 1. Close the bracket. Then I have all over 12. Okay? So at this point in time, we now say this thing becomes 2 into, here is my 2n raised to power 2. N plus 2n will give me plus what? 3 what? N plus this 1 that is here, close the bracket, minus. This is my 3 over here, I'll open the bracket. N times n will give me n raised to power 2. N times 1 will give me plus what? N. 1 times n will give me plus what? N. And 1 times 1 will give me plus 1. Close the bracket, all over what? 12. Okay? So we now come here, bringing this thing inside here, we now say 2 times 2n squared will give me 4n squared. The sign here is plus. 2 times 3n will give me 6 what? N plus. 2 times 1 will give me what? 2 minus. This 3 will turn this n squared. I have 3n what? Squared. This is n plus n, which is 2n. Multiply by this 3, we have minus what? 3 what? N. Okay? So, we'll have minus 6n. Because this is n plus n, which is 2n. 2n times 3 will give us minus 6n. So, the sign here is a plus. When this minus comes in here, it affects the plus, becomes what? Minus. 3 times 1 will give me what? Minus what? 3. All over what? Over 12. It is at this point in time that we look here. I have plus 6n here, I have minus 6n here. So this and this can go. I have 4n raised to power 2 here, minus 3n raised to power 2 here, which I am now left with n raised to power 2. So I have n raised to power 2. Here is plus 2, here is minus 3. So 2 minus 3 will give me minus 1. So I have minus 1 all over what? 12. And don't you see that the variance of a discrete random variable is given as n raised to power 2 minus 1 all over 12, which of course is what we wrote up here earlier, and we say we needed to show it. So that is exactly what we have shown here on the board. How to arrive at the expected value of a discrete uniform distribution and how to arrive at the variance of a discrete uniform distribution. We are going to take one question to illustrate how we can solve problems making use of a discrete uniform distribution. So you permit me to clean the board while we call the questions up. Okay. Yes, this question says, and I read, I have a question here that says this way, and then I will read. That question says, 10 balls, 10 balls are numbered 1 to 10. 10 balls numbered 1 to 10. 10 balls numbered 1 to 10 and placed in a bag. One ball is removed from the bag randomly. The first question asks us, we should find the expected value of that random variable. Second one says we should find the variance of that random variable. The only thing we are going to remind ourselves here to note is 10 balls. They are numbered from 1 to what to 10. And when we talk about uniform distribution, we talk about interval. And the interval is what? A to B. A is the lower bound, and then B is the upper bound. So in this case, I am now going to say that my A is equals 1 and my B is equals 10 to start with. Okay. Now we ask ourselves a question. Is this question concerning a discrete uniform or is it concerning a continuous uniform? It is discrete. Discrete because the number of balls, they are countably finite. They are 10 in number in the bag, numbered from 1 to 10, and they can be counted. So it's not as if it is water or maybe it is talking about volume that we cannot count. So it is talking about discrete uniform distribution. And they are asking us to find the expected value. And you remember that the expected value is given as what? E of x is given as n plus 1 all over 2. The question here is n. N is the number of what? Of outcomes or number of what? Trials. So how many balls are contained there in the bag? They are 10. Numbered from 1 to what? To 10. So my n here is what? Is 10. So I will now say therefore my E of x is given as 10 plus 1 all over 2, which is 11 all over 2, which is 5.5. So the expected value is 5.5. And they talked about the variance. And we know that var of x is given as n raised to power 2 minus 1 all over what? All over 12. We already had established that n is what? Is 10. So what we are going to do here is 10 raised to power 2 minus 1 all over what? 12. And of course, our 10 raised to power 2 is 100. So we have that this 100 minus 1 all over what? 12, which is 99 all over what? 12. Once you get the quotient, whatever thing the value is the variance of that random variable. So the last question they ask us here is that we should find the probability that the number on the ball drawn is between 7 and 10. Permit me to clean here. We should find the probability that the number on the drawn ball is between 7 and 10. So we are looking at the probability. We are looking at probability that 7 is less than what? That x is greater than 7, but less than what? 10. That's what it means. That it lies between 7 and 10. We were not told lying between 7 and 10 inclusive. This is exclusive. 7 and 10 are not involved. So this is now going to be, probability here now is going to be that this is equals probability that x is equals what? 8 plus probability that x is equals to 10 is equals to 9. You see, we did not include 7 here, we did not include 10 here, because it is between 7 and 10 So the numbers between 7 and 10 are 8 and 9. And we have to remember that the probability here is, we are now going to say that this is now going to be the KMF of a discrete uniform distribution is given as, we say recall that P of capital S equals small x is given as 1 all over what? N, for a discrete uniform distribution. And of course, our N here is what? Is 10. So this is now, of course, is now going to be D is equal. For 8, it is going to be 1 all over 10 plus. For this 9, it is still going to be 1 all over 10. And then LCM of 10 and 10 is what? 10. 10 divided by 10 is 1, multiplied by 1 is 1, plus 10 divided by 10 is 1, multiplied by 1 is 1. 1 plus 1 will give me what? 2 all over 10, which gives me 1 all over 5. Because 2 into itself is 1, and 2 into 10 is 5. And that thing becomes the probability that x lies between 7 and 10. Thank you very much thus far. I want to believe that we have not confused you. Still do remember to subscribe to our YouTube channel, as we are committed to making sure that we transform some of these abstract, distributions into something that you can easily lay your hand on. The next class that is going to come immediately will now be on continuous uniform distribution, especially as it concerns proving the variance and proving the expected value of a continuous uniform distribution. Thank you very much.